Hello community, finally we are there, pre-training a BERT model for our SBERT Extreme. Have a look at this article. The inability to fine-tune the models for company-specific data may result in lower than expected performance and ROE. And now we will address this problem. We're going to pre-train a specific BERT model. And you see, normally we would have a huge pre-trained BERT model with billions of sentences, and then we just apply our little fine-tuned BERT model with just 100,000 sentences. And the main task was done on the pre-trained BERT model. But who needs all of Wikipedia, all of the news of 2017 to 2019? We are going to do now the top 500 R&D projects that will finish in 2023. All discipline of science, the most innovative project. I want to see where is EU science heading in 2023. And we will build a pre-trained BERT extreme model, just 50k sentences, and we will build our SBERT information retrieval system. Hello community! Now is finally the time. We are gonna do the pre-training of a BERT model right from the beginning, because we have domain knowledge. And it is about outstanding EU R&D project that will finish in 2023. So I want to know, and I want to build here a special SBERT information retrieval system, but not a lexical search, but a neural search engine to know especially here about R&D results that will come up in 2023. So here we go. If you want to follow along, there is a Colab notebook for you. I'll leave you the link in the description. And I follow here www.pythoncode.com. They have an article, and I thought this is the most simplest article I could find. Okay, here we go. We install our Hugging Face datasets and we install our transformer libraries. And then we, import. Everything is not perfect, but just follow the example. What is nice is on Hugging Face, you have something called a dataset. And a dataset is a library, and they have close, I don't know, hundreds and thousands of datasets already available for you just to download. And this is something beautiful. Let me show you. You just say from datasets, import the list of the datasets, and they have 16,844 datasets. You can download, they are clean, they are perfect, they are configured, you can use them immediately. So you see here, yes, I'm not going to look at 16,000 different data sets, but it is beautiful. Great. Now, what we are going to do is we are going to download a specific data set. It's called CC News. And this is just a data set. I just want to show you how easy it is to download. But as you can see, it takes some time because it has millions of sentences. But the good thing is we don't have to wait for this, because we are going to use a complete different data set. Let me just show you. So let's stop here and let's go on here, because an alternative to the public data sets from Hugging Face is you have your own data set, and I have my own data set. I have here on my Google Drive, I have a specific CSV file. I just copy it over here in my local directory. And then I say, if you have now this Hugging Face dataset and you have it in the format CSV or JSON lines or text or Parquet, which Parquet would recommend, you should be able to use the command load dataset. And then you simply give here the format of the dataset. You have the path to your data files. And this is it. And this is exactly what we are going to do. And then I will show you, yes, beautiful dataset is downloaded. That we do now a splitting in a training data set and a test data set. Now, just for demonstration purposes, I choose here the test data set to be extremely small, .001. So I have about 40,000 elements in my data set, and my test data set will just have 40 examples. So it is just for demonstration purposes. Normally, I would recommend 90% you go with the training data and about 10% you go with the test data set. But this is just for demonstration purposes. Now, we have now for our tokenization, very easy what we do. Jesus, there's some things in here that do not belong at all in here. I'm shocked. So what we do, we split now our Hugging Face dataset format very simply in two text files. We have a training text file and a test text file. This is great. Now, if you already have this and you want to create a dataset, there's something beautiful that's called line-by-line text dataset. And you just prepare a tokenizer, you give the file path to your text dataset, and define a block size, and you can create your specific dataset. Now, we are gonna go on, since we have now here our specific training text file provided, and in there are all my sentences for my special EU projects. So now what we're going to do, we follow along here from python.com, but you see this is not as beautiful as I showed you last time with the tokenization. This is the, let's call it the quick and dirty route, but here we go. You remember normally for the tokenizer, you should have the normalization, the cleaning of the data, then you have the pre-processing, then you choose a specific model, and then you have a post-processing. Now, you can do it quick and dirty that you say, hey, I have some special tokens. I have a vocabulary size. Normally with BERT, it is 30K. I go here specifically with 20K. And the maximum sequence length of your input, normally 512 or 1024. I go for demonstration purposes only with 256. Please go at least with 512 if you do it for a company. And then truncate or not, if you have extra long sentences that go beyond 256 tokens, should it be truncated, yes or no? And for demonstration purposes, I say yes, cut it off, because we do not have such extra long sentences. Beautiful. So what we take now is our tokenizer. And you know we have a word piece tokenizer. And then we just train our tokenizer. The files we have just defined, vocabulary size we have set, our special tokens we have defined here. So quick and dirty version is do it. Now start the training of the tokenization. Yes, and if I do not execute the cell, I should not be amazed that sometimes the system doesn't know what I'm coding. So here we go. Training is done, and my model path, yes, I have here a directory, and then I say, hey, please save now this to my pre-trained BERT. So let's have a look at this. Update my pre-trained BERT. Here's our directory, subdirectory, and there we have our vocabulary file. Let's have a look at the vocabulary file. Here we have our special tokens, beautiful. Here we have our characters. And then we're in BERT. You can see with this beautiful BERT prefix, this is BERT. Great. And we should have, yes, you're absolutely right. How far down can we go? 20,000. This is exactly the size of my vocabulary. If you do it for a company in knowledge, please go with 50,000, 60,000. But I want to be fast. I want to speed up the process just for demonstration. This is where you can optimize it. Beautiful. So defining some of the tokenizer configuration file. This is easy. We have done it already. Lowercase is true. We have defined our token and the maximum length, the maximum sequence length is defined. You can define, of course, here the tokenizer configuration file. Great. So now it's interesting. Now you have more or less two options. Remember when I told you the tokenizer? We have now here the tokenizer. And we have save model my path. We have the config JSON and the vocabulary. Now the config JSON, this here, let's have a look at this. This is a rather unimpressive because this is really just our specific tokens. You have the maximum length, beautiful. So there's nothing specific hidden in there. Now, last time I showed you, if you want to have the fast implementation, the Rust implementation, that we have our transformers, then we say BERT tokenizer fast. and we take the tokenizer that we just defined. This is now our new tokenizer that we have. Just have a look at it, that it's true. You have a transformer model BERT. We have a tokenization BERT fast, and this is a BERT tokenizer fast. Great. Now we're gonna say, okay, please save it. And now we have chosen a different model, a different path, a different directory. And we go with saved model. So here we go, saved model. Yeah, just update anyway. And here we have now four files. We have our vocabulary file. You're not going to believe it. Should be absolutely the same as before. Yes, yes, yes. Also be limited to, oops, come on, to 20,000. Yes, here we are, translator. This sounds very reasonable. Then we have the tokenizer config. This is now in the form you know from my last one. And thank you. And the spatial token map. Yes, this is nothing. You know this, so this is more or less redundant. Beautiful. What else? Yeah, we can check if we really have the fast Rust optimized tokenizer. It is true. And if you look at the tokenizer now in detail, you will see summary. Vocab size is 20,000 tokens. It is fast, it's true. The padding is right. The truncation, special token, unknown separation, padding token, the start token, and the mask token. Because we are gonna pre-train our BERT model on a mask language model. So beautiful. So here we have now our new tokenizer. In the official Colab notebook, I give you the link here in the description, they have a different way. They say, okay, we take BERT tokenizer fast from pre-trained and my model path. So the model path is here my pre-trained BERT. So we have the vocabulary and the config JSON, and they create this now here, a tokenizer. And what I wanted to show you here, that you have here in this way more information available, because you are using here a pre-trained statement. So what you have, they're loading everything that we have, and then they say model config BERT configuration. Now, we are just here on the level of the tokenizer, so it should not, because we have here from pre-trained. Now it accesses some pre-training. But I think this is not the optimal way, but okay, anyway, because you see, we have here our token, we have our lowercase, but then we also have now from the BERT architecture, the hidden size, for example. Then we again have here the mask token that we need, but this is more or less based here in our tokenization. We have now maximum position embeddings, which is an BERT architecture thing. Then again, we have here token, 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 and vocabulary size. So we do have a little bit of a mixture. Okay, they go quick, fast, and dirty. Here, BERT tokenizer fast from pre-train. I prefer my classical method, but whatever method, you can go, no problem at all. Okay, so beautiful. Let's make some place here. Okay, now comes the point. We have to encode it. And encode is now we have our 500 project description. I don't know anymore. And we have now to encode our sentences into this beautiful tensor. Now there are two ways. You can encode it with truncation, where I say after 256 tokens, cut and I forget the rest of the sentence. Or you can say, hey, I want to encode it without any truncation. And you see here, the mapping function to tokenize the sentences pathed with and without truncation is a little bit different. What we do, we apply the tokenizer, of course, to our text. And then either we say truncation is true or not. We have a padding to the max length if we have some truncation. And of course, we want to have our special token mask returned. So this is what you are familiar with. Either remove the columns. Yeah, this is beautiful. And then here, we have, and if you want, there's on GitHub Hugging Face, some beautiful deep dive into language modeling. More or less what it is all about, it is the main data processing function that will concatenate all text from your data sets and generate chunks of maximum sequence length. So Nothing special about this. This is a very simple code. We say, yes, beautiful. Let's just show me the result. Again, my training data set, remember, had 39,000, close to 40K, and my test data set was extremely small, just with 40. Yeah, the training data set, and you have a look at the training data set. Beautiful. You see here, we have the features. We have our text, we have our input IDs, our token type IDs, our attention mask that we need to differentiate between padding token and real token. We have a special token mask, and the number of rows is here 40K. Great. So this was the Tokenizer configuration. You might say, beautiful. Now, finally, we are coming to our BERT model. We can now design our BERT model. Congratulations. And we have in Hugging Face some class defined for us, and this is the beautiful class of transformer.BERT configuration. So here we have everything we need. We can define our vocabulary size. We can define the hidden size, the number of hidden layers of BERT, the number of attention head in the BERT layers, the intermediate size, the hidden activation, the dropout rate, the attention dropout probability, the maximum position embedding, whatever you want, we have it here. I have here the link for you, Hugging Face Transformer. This is BERT config. Have a look at this. There's where the magic happens. Again, what is the hidden size? Simply dimensionality of the encoder layers and the pooling layer. The number of hidden layers, default to 12. We can set it 24, whatever you like. It's the number of the hidden layers in the transformer encoder, the encoder stack that we have, that is important. The number of attention head, also default to 12, is simply the number of attention head for each attention layer in the transformer encoder. Beautiful. Intermediate size is the dimensionality of the feed-forward layer. Hidden act is some nonlinear activation function, and you can choose between Gelo, Relo, Swish, or Gelo new. Hey, Gelo new, I don't know, new. Okay. So there is all the magic happening, and we're gonna do this now. So we're gonna say we initialize now the BERT model with some configuration. We say, okay, our vocabulary size is exactly the vocabulary size of our tokenizer. Maximum position embedding has a maximum length, also defined with our tokenizer. And then you can go and say, hey, number of hidden layers and a number of attention add-on, whatever, we go with default, with 12. You see, 12, 12, we go with the minimum configuration because I just want to show you how it works. So we define the BERT configuration file. Now, yes. Model configuration file. Let's have a look at our configuration, that you see what we have created. Beautiful. Here we go. BERT model configuration file, the design of our BERT model. We have, where are we? The number of hidden layers is 12. The number of attention head is 12. Our model type is a BERT model. Yes, our maximum position is 256. Our vocabulary size I reduced because I have just only 500 EU research projects, and I don't need some vocabulary about American presidents or whatever, or about news cycle or whatever. So I go with 20K. Please try it out for you specific. Play around with this a little bit. Gives me the actual transformer version. What I have, intermediate size, yeah, the hidden size, what classifier dropout, attention dropout, you can set it. This is our BERT configuration file. And you're not gonna believe it, we use this BERT configuration file now for our BERT model. But we're now doing the pre-training of the BERT model. So we have nothing from pre-training that we can load, neither the architecture, which is now defined in our config file, nor the weights. Normally, when you have BERT from pre-trained, you also load the weights from the Hugging Face model. This is not gonna happen here because we are starting. There are no weights available. So beautiful. So the pre-training of the BERT model originally in 2019 was on two heads, on two tasks. It was about the mask language model and the next sentence prediction. I leave you the link to the original archive preprint in the description. So what we are gonna do, we are not gonna train it on MLM and NSP, but experience has shown if you train it on MLM alone, on mask language modeling, so when you mask out words in our sentence, that this does the main job of training, pre-training. So beautiful. And you're not gonna believe it, there is already a class for us here, and it is called BERT for mask language modeling. And the BERT configuration file. And this defines our model if we start with pre-training. You will say, hey, isn't this beautiful? Yes, it is. I know you are amazed. So yeah, just that you see, normally what we do is we have a BERT model, and then we say from pre-trained, and we take a BERT base model. All this is not available. We do not download anything from Hugging Face. We define the BERT architecture that we want to have, 24 layers, 256 layers, whatever you can afford in compute time. And we're gonna start right from scratch. Great. So yeah, if you want to have a look at this, yes, let's look at this. Why not? Here, BERT for mask LM. This is a transformer class that is defined for you. Here are all the different parameters you can have a look at, you can play, you can optimize. Whatever you want to do, everything is here for you to play around and to optimize your model. Talking about the model, so what we have. This is now our model. Maybe I need some more place here on the screen. Let's start from the beginning, very beginning. No, yeah. Here we go. So we have a BERT for mask language model. So here we go. At first we have our embedding, beautiful, and then we start with our encoder. You're not gonna believe it, and we have self-attention, yippee, yippee, yeah. So first BERT layer, and then second BERT layer. And then we go up 11, where is it, 9, 10, 11, 11th BERT layer, beautiful. So, and then output, beautiful, and then we have here this additional training head. We do the pre-training of BERT on the mask language model, and this here is now our training head. As you can see, it's more or less a simple linear structure with an activation function. Here we have GELU. Beautiful. Yes, you know everything about here. I don't have to tell you anything about it. Yeah, just a reminder, the original BERT was trained on 2 heads. And if you want to do this and train it on 2 heads, so next sentence prediction and MLM, there is also a specific predefined class for you on Hugging Face you can download, and it is class transformer BERT for pre-training config. And they have here a BERT model with 2 heads already programmed for you. You just have to execute the command. Great. So now that we know we have mask language modeling, a specific head, how we do the masking? My God, how do we have to code this? No, everything has been taken care of. It's beautiful. So how we do the masking for our first task. And there's something, maybe you know it, it's called data collators. And they are objects that will form a batch by using a list of dataset as inputs, and they are beautiful. And some of them, and you're not gonna believe it, data collator for language modeling, yes, it exists, also applies some random data augmentation, like random masking, on our formed batch. Now, isn't this a coincidence that we find this here? If you want to find out about it, here is the link, Hugging Face data collator, and you get every information about this. And as you can see here, we go here, data for language modeling. This are here our specific class that we're going to use. Gorgeous. I know, I know. So yeah, I leave you the link in the description. You can have a look at this in detail. We have a tokenizer. We have the masking task. You can now define the amount of masking. Normally it was 15%, some say 18%, sometimes go 20%. Let's go with 20%. I mean, this is really up to you to choose the amount of masking. Of course, it has some effect on accuracy, but also compute time. So what we get back, what kind of object is this? Well, it has all our information that we have. It has our vocabulary size, we know where it is. We have Rust optimized. We have our masks, our padding, our separation, our unknown, everything else. We have our probability for the masking. Great. So we have generated now here our data collator, which does the masking for us. If you have multiple GPUs, please install Accelerate. If not, like we are here working on a free Google Colab notebook with just one GPU, we go now into training arguments. This is hell. They are training arguments. My goodness, I have here the most important you should know about. My model path. I think it's my model path. Model path. Just hold on. Where am I? Tokenizer first. My model path. Yes. Here we go. My model path. Yeah, now it recognized it. Beautiful. This is simply our output directory. Evaluation. Yes, we all write it. The number of training epochs, you know this. If you're rich, you can afford more. Per device training batch size, 16, 32. Let's try 32. I don't know if it works. Gradient accumulation per device, batch size, logging steps. I have put it really down because, as I will show you, it takes quite some time and I want to see some results very soon. I save it every 100 steps. You have auto-find the perfect batch size you can activate. You can load the best model at the end. Of course, you can define the total limits of model. You want to save everything. You know this. Beautiful. Let's define now our training argument for the pre-training of BERT, our training parameters. Default values will change in version 5. Yes, beautiful. Just to have a look at the complete set. Wait a second. So here we go. If you really want to optimize, there's Adam for the Adam optimizer. You have beta 1, beta 2, your epsilon. You can have here define a seed. Number of workers, disable evaluation, delay step, Jesus, whatever you can think of. You have here what you logging DMI runs December. Hey, this is today. I'm giving away when I'm doing this. Oh, wow. No CUDA, yes, optimization. You can push it to the Hugging Face hub so the other people can use it. Safe strategy. You can use, of course, a TPU, of course, no problem. The warm-up ratio, everything. Okay, so, but here we go. Now this is almost the most important line because now we pre-train our BERT model. So we have our trainer, we have defined our model, we have defined our arguments for the training, we have defined our data collator with the dynamic masking. We have a training data set and we have a test data set. And you say, this is it. Yeah, this is it. Congratulations. And then comes the moment where trainer.train. Beautiful. So as you can see, now here we go. Yes. I don't need this. So have a look at this. And here we go. Just waiting for the first time estimation that I have the minimum amount of vocabulary. 20K is minimum, yeah? No way you can go below 20K. I have the number of epochs limited to just 10, yeah? You need, I don't know, 1,000, 10,000, 100,000 epochs to really, you need a lot of data. The pre-processed, pre-trained model, BERT model, you can download from Hugging Face. They have been trained on millions of sentences for days and weeks on multiple TPUs. So the more data you have, the deeper your BERT model is, the higher the dimensionality, the better, of course, is your model performance. But this is just here for demonstration. I don't know if you have a GPU or maybe you have 2 GPUs in your local system, or you can say, hey, I have so much money, I can go to AWS and I can spin up a GPU cluster with, I don't know, 10, 12, 24 GPUs. Great, do it. It is unbelievable. It is fantastic. But just to show you, if we do it here on a free Google Colab notebook with a GPU, runtime GPU, Yes, I have a GPU activated. You see here, even in my minimum configuration, it is 4 hours and 41 minutes. And I just want to let it run for some minutes to show you where we are. Here. We have 10 steps. Wow. So our training loss is 9.1, so high, and validation loss is 8.6. So therefore, that we have such a limited validation set of sentences, this is not bad at all, but of course, this is just the very first one. So I would say let it run for 10-15 minutes. Let's have a look if we go in the right direction. And then I would say this is it for the pre-training of our BERT model, of your BERT model, that you know now how to do the pre-training of a very specific BERT model on your specific data set. Choose a scientific data set, choose a legal data set, choose a whatever you like data set. You can really optimize your system on, if you work for companies, if you work for clients, on the client data sets. But you have to be aware of that the pre-training, this is really where the system gets the main knowledge before you can fine-tune it. The pre-training is really intense. It is time intense, it is resource intense. If you have at home a GPU, as you can see, maybe you can afford at home to let it run for 10-12 hours minimum, maybe even for 2-3 days, that you get, even with a limited data set, some good results. Here is really the training time, the amount of training you invest here. This is the critical element for the accuracy of the model. So I would say let's wait some minutes and I will be back with you in a second. So, and after about close to 10 minutes, you see here we have now 50 steps, the first 50 step, and the training loss, if you look at the training loss, 9.185817976. Yeah, it's going in the right direction. I mean, it means nothing because we have to do the training, but at least it's not diverging. And validation loss, you're not gonna believe this. 8681807674. Yes, beautiful. It looks, it could be converging to our solution, but as you can see, it would take about 5 hours here in our simplest version on this free GPU. I had a question from one of my viewers. If you want to recreate the original BERT model, the training, what would it cost? I can tell you I've read an article. If you do the BERT training in the traditional form on the Wikipedia and the English book corpus on AWS, and it is now at the end of 22, beginning of 2023, it would cost you between $1,800 and $2,000 compute time on AWS. I have not done it. This is just an information I received. So just to give you an idea, if you want to do the classical BERT model for Wikipedia, so for everything, if you want to have a very general approach, including the news and whatever, blah, 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 it costs you about $2,000 on AWS as a rough estimation. Please do not quote me on this. This is just to give you a guideline. If, of course, you have a GPU or a TPU system at home and you can use it and you just have to pay the electricity bill, well, even better. Hey, step number 60. Yes, it's still going in the right direction. Beautiful. I think we should stop the demonstration here. Who knows what's going to happen with the system? I hope you enjoyed it a little bit. We have now a system, a model that is now trained in about 5 hours time and that you can use now as your specific BERT extreme model trained on here EU research that will be published in 2023. We have here the project description. We know what are the topics that will emerge in 2023 on R&D in Europe. And I hope you enjoyed it a little bit. I'll leave you the links to all of what I told you in the description of this video. And I hope to see you in my next video. So just to finish up, if we have now a BERT model pre-trained on European research topics, you just duplicate it. You remember in SBERT, our sentence transformers, we have 2 identical BERT models with some connected weights. And then you just train your SBERT model. There are just 3 lines of code to build your SBERT model from your BERT model. And you train your SBERT model, let's say, on the American research and development models that will be executing in 2023 or 2024. And you compare now then the European R&D sector to the American R&D sector in your specific domain area and with your domain knowledge. So you have created an SBERT model specifically for some, I don't know, domain-specific knowledge, and you can build now an information retrieval system, a neural system that is not a lexical system, but this is a semantic neural information network. Congratulations!